Jai Hind. Myself, Dr. Amita from Ajay Kumar Gar Engineering College, Ghaziabad, affiliated to AKT University, NAC A++ College, accredited by NBA2 and NAC A++. So here in this video lecture, I will take some difficult questions from the Opamps and which may come in your examination. We will solve some numericals which are bit difficult to what we do for the syllabus coverage, but here there are some more practices required always, so we will deal with some another numerical. So here the first example which I am going to take is, let's say, starting from a simple one, and just we are going to revise the concept once again. So here, let's say this particular numerical is being given. So this voltage, in the earlier lecture I have discussed that we are considering Opamp to be ideal, and the second point is that we will apply the virtual ground concept for the Opamp, and we will check whether this RF is connected to the negative terminal or not, and then easily we can apply the Kirchhoff's current law. So there are two concepts which we are applying after checking the two conditions that Opamp is ideal. Second one is RF connected at the negative terminal. So if these two conditions are satisfied, we can proceed for virtual ground concept, and then the KCL we will apply, right? So here this point potential is 0 volt. So this is also 0 volt, right? Now applying KCL at this point, let us say this point is A. So applying KCL at node A. Okay, applying KCL at node A. So we will apply this V1 minus 0 upon 33 into 10 raised to the power 3, which we did earlier. We will do the same, plus V2 minus 0 upon 22 into 10 raised to the power 3, plus V3 minus 0 upon 12 into 10 raised to the power 3 is equal to 0 minus VO. This is VO. 0 minus VO upon R. Okay. So putting the value of all these 0.2 upon 33, okay, plus minus of 0.5 upon 22, we will take 1 upon 10 raised to the power 3 as common, plus 0.8, okay, upon 12 is equal to minus VO upon RF. Since RF value is not known, so we will consider as VO is minus RF into 10 raised to the power 3, and here is the answer. So this was to just revise the concept which already we have done. So VA would be this value. If RF value is known, we can just put the value of RF and we can solve for the value of the output voltage. Okay. Next. We have given a circuit which is consisting of 3 Opamps. In the figure, we have 3 Opamps in the circuit, that is one Opamp, and then this is one Opamp, second Opamp and third Opamp. Now how we will proceed for the numerical. So in this particular numerical, we have been asked to calculate the output voltage VO, right? The output voltage VO we want to calculate. As all the op-amps are ideal and we have to apply the Kirchhoff's current law, then applying this Kirchhoff current law, we can see here the potential of this point. The potential of this point is 0 volt. The potential of this point is also 0 volt, right? Okay. So now, if this point potential is known, then I can apply KCL at this point now. I can see here very clearly this minus 20 millivolt is the potential of this point. So this point potential is also minus 20 millivolt, right? If this potential is known, I have this point potential. This is also minus 20 millivolt because this is one point, right? If we see very carefully, there is no resistance between these 2 points, then the voltage of this point is minus 20 millivolt, right? Okay. Now, this is minus 20 and this is 0 volt, this is 0 volt. Now, we have to find out the value of this potential. Let us say this is V. Because without finding this V, I cannot reach to this VO. Without finding this intermediate voltage V, we are not able to reach at the output point. So let us find out the potential of this point, intermediate point, that is V. Okay. So coming to that, making the equations. So here this is 0.025 volt. This is minus 0.020 volts. Everything I am applying into volts. So here I will apply KCL at point A. So at node A, KCL at node A. So this is 0.025 minus 0 upon 15 into 10 raised to the power 3. This point voltage, these 2 point voltage, only one resistance is there. So 0.025 minus A upon 15. 0.025 volt minus 0 upon 15. Similarly, this point, there is one resistance. So I will apply the same, minus 0.02 minus 0 upon 30 plus minus 0.02 minus 0 upon 30 into 10 raised to the power 3. These two currents, this and that is equal to this much of current. This is 0. This point to output node upon 600. This point to output node upon 600, right, is equal to 0 minus V upon 600 kilo ohms. From this equation, I can easily find out the value of this V. If this V is known, now I can go to the another. This is my equation 1. Okay. And from here, V can be calculated easily. Okay. Whatever is the value. Now, ultimate aim is to find out the value of VO here. the value of VO. So now what I will do is, this point voltage is 0 because this is 0, right? This point voltage is known. Now I can apply the concept. Minus 20, 0, minus 0 upon 15. V minus 0 upon 30 is equal to 0 minus VO upon 300. Like this for the third Opamp. So the second equation will be minus 20 minus 0. In fact, this should be minus 0.02. This is minus 0.02. Minus 0.02 minus 0 upon 15 kilo ohm plus V minus 0 30 into 10 raised to the power 3 is equal to 0 minus VO upon 300. Cut the 10 raised to the power 3 values. Okay. If this V is known from here, we can easily calculate the value of V. Okay. So this VO can be calculated by this expression, minus 0.02 upon 15 plus V upon 30 and multiplied by 300, and here it will be a minus sign. So put the value of V and you can calculate for the output voltage, right? So in this way, nothing new we did, but the concept which have been applied is a very simple concept, and by applying the simple concept of virtual ground concept and the Kirchhoff current law, we can solve any numerical for the Opamp circuit, right? Now coming one more circuit of the Opamp which usually comes. So let us solve one more important numerical for the Opamp. So here example number 3. Okay. Now let us do this numerical. This numerical says, find out the value of R. Find out the value of R if the output voltage upon input voltage or the gain of the op-amp is given to be -10. Okay. Here gain VO upon Vin is given as -10 and the question is asking for the value of R, right? What is the value of R if the gain is given? Now the concept will be always same. So we will apply the concept. Here some changes are there. Op-amp is ideal and the feedback. Feedback is some circuit of resistances, and now we will apply the virtual concept which says if this is 0 volt, this will also 0 volt by VGC. Some current I flows here, this flows, and here this current will divide into between two resistances I1 and I2. So for I is equal to I1 plus I2. So if this I is equal to I1 plus I2, I have to find out the value of R. Now what to do? At which point we have to apply for the KCL? Now I will consider 2 points. If I don't have this point potential I know, but this point potential I don't know. So I will consider some voltage at this particular point V so that I can go for my KCL value, right? So first of all, I will apply my KCL at this point and then I will apply my KCL at this point. So applying KCL first at this A point and then I will apply my KCL at this B point. So here applying KCL at A point, at point A. So Vin minus 0 upon the the resistance between these 2 points is equal to 0 minus V this 2 points upon resistance. 0 minus V upon 5 into 10 raised to the power 3. Now we have V is equal to minus 5 V in upon 3. Now this is the relation which we got for relationship between V and V in. Equation number 1. Now I will apply KCL at point B. In the similar way, this point potential minus this point upon 5 kilo. So 0 minus this point potential is V upon 5 into 10 raised to the power 3. Okay. This point potential minus 0, okay, is equal to, see, this current I is equal to I1 plus I2. So I2 will be V minus 0 upon R. And I1 will be V minus VO upon 10 raised to the power 3. Now I have V in terms of V in. So I will put the value Now only one thing is needed. You have to solve these two equations. So first equation have been made, and this is the second equation. You can put the value of V in this equation, and then we can divide VO upon Vin as been given by -10, and we can get the value of R from this second equation. So we will write it in place of V. We will write 5 Vin upon 3 into 5 into 10 raised to the power 3 is equal to again minus 5 upon 3 Vin upon R, right, plus minus 5 Vin upon 3 R into 2 raised to the power 3. Right. Minus VO upon 2 into 10 raised to the power. Now keep all the terms here, the R values all here, and divide by Vin. So just we can divide by Vin. Just erase all the Vins. Okay. And see what I am doing is Vin will come here, and now this VO upon Vin has been given as -10. So we will put the value 5 to 5 cut 1 upon 3 into 10 raised to the power 3, right, plus 5 upon 6 into 10 raised to the power 3. Okay, take here, and this one also, plus minus 10 upon 2 into 10 raised to the power 3, and that is equal to minus 5 by 3 R. From this equation, we can calculate the value of R. Okay, so by simply applying the concept of virtual ground and the KCL at different nodes, we can go for the output result, and any output can be find out for the Opamp circuit. So here you have to keep in mind that Opamp should be ideal, and apply VGC, virtual ground concept, and then apply KCL at various nodes. As required. Make equations and solve. By using 3 simple steps, you can get answer of any Opamp numericals. Thank you. Jai Hind.